we notice here that our feeder is actually a single phase. Okay. So this feeder can also be three-phase. So this feeder can also be three-phase. Okay. And like what we have discussed before, it just means that it comes with L1, L2, L3, and a neutral. Okay. And from here, we are able to create three phases. Okay, so L1 and neutral, L2 and neutral, L3 and neutral. Okay. And we tabulate this in a table like this, L1, L2, and L3. Okay. And then we start to assign to each of these three phases. Okay, we have three here. A motor each. So we can have A going here, A. We have B to the second one, C to the third one, D back to first one, E and F. Okay, so our aim is to make all this as balanced as possible. Okay. So in this case, it's good we have an even number of motors, so we are able to have a very balanced system. In fact, all of them are the same. Okay. And for three-phase system, what do we need to do? We don't have to look at all three of them as simultaneously or concurrently. All we need to do is to identify the largest phase. Okay. If we are able to meet the requirement of the largest phase, by the implication, we should be able to meet the requirement of other phases as well. So for three-phase system, we have to just focus on the largest. And in this case, there is no distinction because all the three of them are drawing the same amount of current. But for the purpose of this example, we look at phase 1. Okay. So before we move on, John has a question. Referring back to step 2 just now, he's asking, okay, he's asking, okay, he's asking here. I need the table. Okay. So instead of choosing 20, will you be marked wrong if you choose 16 amps here? Correct? Because we know our design current is 15.9. So if this number 16 appears in the list provided, you will be considered correct. Okay. Okay. Yeah. So we will make it very obvious for you for the purpose of assessment. But now that we know 16 is not a common rating anymore, we have taken it out from the list. So you're likely to end up choosing 20. Okay. So thanks for the question. I think, yeah, it's good to clarify. Yeah. So back to this example, we are only going to look at one of the phase. Okay? So we see where will the differences comes in. Nothing has changed. We take 100%. the first largest machine. So we have 6.236 here. Then we take 80% of the second. So this is the first, this will be the second. So that will be 80%. And you notice that in this single phase, there is no more motors. Okay. So for the last aspect, 60% of the remaining, it is actually 0, not required. So we end up with only 11.45 as the maximum demand. Okay. So remember, for three-phase system, we will only consider the largest phase. Okay, and you notice that now, looking at one of the phase, we do not have motors under this category, no more. And we move on, knowing that the maximum demand cannot help us to size the circuit breaker, we have to use the design current. Okay? And what we do is we simply replace the full load current of the largest machine by circuit breaker rating, which is 20 here. We end up with 25.1. So we will choose 32. Okay, so in this case we cannot choose 25 because it is 0.1 more than that. Okay, so it's not a prudent choice. We will go for the next available size, which is 32.